Welcome again to our topic on introduction to electrolysis. It's another of the many sessions we'll do in chemistry, trying to make chemistry very simple. This is a very simple topic and we'll be able to cover it in a very short time. My name is Simple Teacher. Let us start by defining what electrolysis is. This is the decomposition of a compound by an electric current. Simple as that. On decomposing, the compound is called an electrolyte. So as it is being decomposed, it is called an electrolyte. There are those that are classified as strong electrolytes, and these are fully ionized. And examples are all amino acids. We are talking here of hydrochloric acid, sulfuric acid, and nitric acid. All strong alkalis. These are normally sodium hydroxide and potassium hydroxides. And also all soluble salts. Remember from our topic on salts, there are those that we said are soluble, and those are very strong electrolytes. Weak electrolytes, these are electrolytes that are partially ionized. Examples are all organic acids, all bases except sodium hydroxide and potassium hydroxide, and water. There are those compounds that are not electrolytes, or elements that are not electrolytes, and these are not decomposed by electric current. They exist as molecules and therefore cannot be ionized. Examples are organic solvents such as petrol, paraffin, ethanol, and benzene. Others are hydrocarbons, including alkanes, alkenes, alkynes, and also the chemicals of life such as proteins, carbohydrates, lipids, and starch. Those are non-electrolytes. Now, in solid form, electrolytes do not conduct electricity because ions are joined, they are fused. But while they are molten, the ions are mobile. So that is when they can be able to conduct electricity, when they are molten or when they are in aqueous or solution states. Otherwise, when they are in solids, they cannot be able to conduct because simply ions are not mobile. So we define what is a binary electrolyte. This is an electrolyte that is composed of one type of anions and one type of cation, e.g. magnesium oxide, which has some magnesium ions that are cations, and oxygen ions, which are anion. So non-binary electrolytes are those that have more than one type of cation and or anion. And these are those compounds that are in aqueous or dissolved in water state. Like if you dissolve sodium chloride in water, it will have during electrolysis you will have four types of ions. You will have the sodium ion, you will have the chlorine ion, you will have the hydroxide ion from water, and the hydrogen ion from water. So in that state, this will be an non-binary electrolyte. So what is an electrode? An electrode is a rod through which current enters and leaves the electrolyte. These are the rods that are dipped in the electrolyte and then connected to the positive edge of the setup or negative end of the setup, and these are the ones that allow the current to come in, and this at this point this is where electrons are gained or lost. So they should be inert, and these electrodes are commonly made of platinum or carbon graphite. Those ones made of platinum is very expensive, so they are very expensive. They are not common in school labs. In school labs we use the carbon graphite, which are made of easily available materials from dry cells, which are easy to find within the environment. In a typical electrolysis setup, there are two electrodes. There is the one that is positive electrode, we call it anode, and this is where the current enters the electrolyte, and this is where electrons leave the electrolyte. We will be able to discuss this in a short while. but what you need to note is that anode is the positive electrode, and this is where current enters, and this is where electrons are discharged. There is also the cathode, which is the negative electrode, where current leaves the electrolyte and electrons enter, or electrons are gained. So in an example setup, or just to represent this diagrammatically, you can see that these are the electrodes. These as you can see, it is connected to the negative head of the cell, and therefore it is the negative electrode which we call cathode. This other one, as you can see, it's connected to the positive head of the cell, and therefore it is the positive electrode which we call anode. So we'll describe what happens during electrolysis. Actually, what happens is that remember, we are using an electrolyte, and most of the electrolytes have both positive ions and negative ions. Let me give you an example of magnesium oxide. Magnesium oxide has both magnesium ions, which are cations or positively charged, and oxygen ions, which are negatively charged. So you will find that within the electrolyte, the oxygen ions, which are negatively charged, will be attracted to the positive electrode. As you know, positive charges attract negative charges, and negative charges attract positive charges. So you will find that oxygen will go to the anode, the positive electrode, and magnesium ions will go to the cathode, the negative electrode. So exactly what happens during the electrolysis. At the anode, the anions, the negatively charged ions, are attracted there. And when they get there, remember, for them to become negatively charged, they had gained electrons. So when they get there, they lose those electrons and return back to their atom. Because they have lost the electron, they are no longer ions, now they are atoms. So what happens is that the negatively charged ions are attracted to the anode, where they lose electrons to form the atoms or molecules. So what happens there is oxidation. Remember, oxidation is the loss of electrons. So in terms of half reaction equation, you remember that it is a negative because it is an anion, and here what happens, it is that it is losing electrons. Remember, we said you cannot put minus electron this side, so what you do, you move the plus e this other end, and here remember it becomes now an atom, so it doesn't have the charge. It is no longer an ion, it is an atom. So that is what happens at the anode. At the cathode, the positively charged ion, which is the cation, is attracted now to the cathode. Remember, cathode is the negative electrode, and here they gain electrons. Remember, they had lost electrons to become the ions. So now to come back to being atoms, they will have to gain those electrons. So they gain electrons to form atoms or molecules. So here what happens is reduction. In terms of the half reaction equation, you see that this is the ion, it gains an electron, and then it forms an atom or a molecule. A molecule, like in gases, two of the atoms will combine to form molecules. I want to give you an example here of what happens using electrolysis of lead 2 bromide. So as we are saying, remember, lead 2 bromide, there are two electrons, there are two ions here. Remember, there is the lead ion, and there is the bromide ions. There's lead ion and there is the bromide ion. Forgive me for assuming that this was chlorine. So there is lead ions and bromine ions. The lead ions are the cations, they are positively charged, and the the bromine ions, sorry, are the anions. They are negatively charged. So what happens at cathode? Remember, cathode is the negative electrode. So at cathode, lead ions will be attracted there because they are the ones that are positively charged. Remember, cathode is negative, lead ions are positive. So positive will be attracted to the negative. They'll go there and acquire electrons. Once they acquire electrons, now they become lead. They become lead to form lead atom. So you will find that what will be observed there is that you will see specks of gray metal. Lead is gray in color. You will find them deposited down there at cathode. As you can see here, these are the specks of gray metal, the molten lead, which has been deposited there once the ions of lead gained electrons and became lead metal. So that will be the observation. In terms of the reaction, as you can see, the lead 2 plus 2 electrons, because the charge is 2 plus, to get lead metal. So at anode here, this other end, you will find that now what goes there are the bromine ions. They lose electrons. When they get there, they lose electrons, and now they form bromine atoms. A combination of two bromine atoms creates bromine gas. So what will be observed there is bromine gas in brown color. So you will observe some bromine gas, brownish gas fumes being emitted here at the anode. So in terms of the reaction, you find that bromine minus produces bromine gas. Remember, bromine gas has a 2 here for it to be a gas. These are 2 atoms of bromine, and in that case, if the gas is formed, that means that 2 bromine ions must be the ones that will form the bromine gas. So you, to balance the equation, you have a 2 there, and then of course, because there are 2 here, two electrons are being lost. Remember, we said you can't write 2 bromine minus 2e to form bromine gas, so there is no minus on this left side of the equation. So you take the electrons to the other side and you write plus 2e. So basically that's what happens in the electrolysis of lead to bromide. In terms of magnesium oxide, as another example in molten state, the ions here is magnesium 2 plus, which is the cations, and oxygen 2 minus, which is the anion. So at cathode, the magnesium ions will gain electrons and be discharged as an atom. So you will find some silver deposits of magnesium metal will be accruing down there at the cathode. So in terms of the reaction, you will find that it is magnesium 2 plus 2 electrons to form magnesium metal. Straightforward. In terms of the anode, oxygen ions will lose electrons and be discharged as a gas, of course a colorless gas which will not be visible, but it will be discharged at the anode. So you will find that O2 minus to form O2, you will find that because you want to form 2 atoms of oxygen, you must have two ions here, and once you have 2 ions here, that means that it will be 4 electrons, because each ion has 2 minus as the charge. So that's what happens in electrolysis. I hope now it is very clear, and every one of us can be able now to understand and easily deal with any questions that come in electrolysis. Uses of electrolysis: 1. Purification of metals, 2. Extraction of metals, and 3. Electroplating of metals. So that's all in this topic, and so many questions are asked in KCSE and other exams. For example, in 2021 paper 1, there was the element sodium, magnesium, and aluminium belong to group 1, 2, and 3 respectively. Select the element with the highest electrical conductivity and give a reason. I think that one you can even get from your topic, the topic we covered on atomic structure and periodic table. Then complete table 1 complete table 1 to show the products of electrolysis for concentrated sodium chloride and molten sodium chloride. So you should be able to deal with that and be able to get the correct answers. Look at that. These are the question. Draw a label diagram of the setup of apparatus that can be used to electrolyze lead 2 bromide. We have just done it. 2020 paper 1 again, state one factor that affects the preferential discharge of ions at the cathode. You know, sodium sulfate was electrolyzed using inert electrodes. Write the equation of the reaction that takes place in cathode and anode. Should be able to give that. 2019 paper 1, draw in the species profile variable diagram of the setup of apparatus that can be used to electrolyze molten lead 2 bromide. We have done it. 2018, explain why a solution of sodium chloride conductor is reactive while that of sugar doesn't. That you can be able to answer. So I think with that we've covered this topic and simplified it. Thank you very much. Let us meet next time when we look at another topic.